Hello everybody, welcome to another video lesson. Today we're looking at rotation of conics. After today we'll be able to graph and find the rotation of axes to write equations of rotated conic sections. Okay, so let's get right into it. Okay, rotated conics. All right, so far we have been dealing with conics that are parallel with our coordinate axis. Okay, so we have our xy axis, right, and then they are parallel with said axis, right? Okay, but now we're looking at what happens if we have a rotated, okay, conic. Okay, so it's rotated from that axis, and that happens when we have this right here, this bxy term, okay, in our general form of our conics, okay? So what happens is we need to think of this in terms of this new axis that's formed, or these new axes that are formed, and we call it the x prime y prime plane. Okay, so what does that look like here, kind of visually? That looks like, let's see if it'll come up. It looks like this right here, okay? Oh, this right here, okay? So we've got our xy plane, okay, like we had up here, okay? But now, instead of having an ellipse, right, that's like this, okay, and that is parallel with that xy, okay? Now it is rotated, okay? So if we can see that, and we're rotating about this theta angle, okay? And now we have this new x prime, y prime, okay? So that's kind of what we're looking at with this rotation of conics. Okay, so let's take a look at this. Okay, we've got this point here, okay? This point P, it's got coordinates x and y, okay? And we can look at this in terms of these triangles, right? Okay, the base of this triangle is x, the height is y, and r is going to be our radius, okay? We've kind of looked at points like this before when we're looking at kind of trig and all that, okay? But, okay, what if we take a look at this in terms of a rotated axis, or this new axis, this x prime, y prime plane, okay? So if we were to go ahead and rotate our plane, okay, now we have x prime, y prime, as you can see here, and then this distance here, okay, if I go ahead and kind of extend this, right, this is going to be my x prime, and then from this x prime axis up, okay, that's going to be the distance y prime, okay? And then we can see here, we can look at this in terms of, again, two legs on a triangle here, where now instead of the triangle being x, y, and r, okay, it's x prime, y prime, and r. Okay, so that's kind of what we're looking at here. And I'm going to go ahead and define these angles here that we have. So we've got theta, okay, that's from our x-axis to our x prime axis, right? And then I've got alpha, that's the angle from our x prime axis to our this r that we have here, okay, this radius on both of these triangles, right? Okay, so in order to go ahead, we're going to prove a couple of equations here first. Okay, and we're going to need to use this information that what is cosine and what is sine. Okay, we know cosine of, again, we're looking at alpha here. Okay, cosine of alpha is going to be adjacent over hypotenuse, and sine is going to be opposite over hypotenuse, right? Okay, so if this is our kind of orange and blue triangle, right, then adjacent, okay, to alpha is going to be this leg right here, which is x prime. Okay, over the radius, and then for sine, okay, the opposite is going to be this leg right here, which is going to be y prime. All right, so that over our radius. Okay, so now if I go ahead and solve that for x prime and y prime, okay, all I have here, I'm just solving for x prime here, so I multiply both sides by r, so I get x prime equals r cosine of alpha, and I get y prime equals r sine of alpha. All right. Okay, so now let's take a look. What if I'm looking at the cosine of alpha plus theta, okay? So that's the cosine of these two combined, right? So that's the cosine from the x-axis all the way to this r that we're looking at, okay? This radius, or this hypotenuse for both of our triangles. Okay, well that's just going to be, it's going to be x over r, right? Hopefully you can see that with this blue triangle that we set up here, okay? X over r. Okay, so again, if we solve that for x, okay, then we just multiply by r both sides. We get r equals cosine of alpha plus theta, all right? So now we need to use our cosine sum identity, all right, which we've done in previous chapters, all right, and we're just going to go ahead and start simplifying this cosine of alpha plus theta here. Okay, so we have x stays the same equals r stays the same. So now instead of cosine alpha plus theta, we get this cosine alpha cosine theta minus sine alpha sine theta. Okay, this is just how this kind of expands, all right? Okay, so now I can go ahead and distribute my r, okay? And now hopefully you see, okay, well, what do we have here? Well, what we have up here, or what we have here with our r cosine theta and r sine of theta, is what we just solved for up here, right? That just equals x prime and y prime. Okay, so we can go ahead and simplify this down to say that x is equal to x prime cosine theta minus y prime sine theta. Okay? And we want this in terms of theta, right? Because that is the angle that we are really rotating this axis. All right? So now again, if I have sine of alpha plus theta, okay, so that's going to be, again, we're working on this blue triangle, that's going to be y over r. Okay, and then if I solve for y, like I did previously, this is what we have, and using, again, our sum identities, okay, and then distributing, okay, same process that we did up here. Okay, again, we find that we have r sine alpha and r cosine alpha, okay, which we just solved for up here being x prime and y prime. So we get these two equations right here, all right? So make sure we have this all written down. And if I go ahead and solve this for x prime and y prime, okay, we're going to be using these two equations also later on in the lesson, okay? So let's make sure we have all four of these written down when we solve for x and y, and when we solve for x prime and y prime. All right, so let's look at eliminating our xy term, and why might we want to do that? Well, when I have this conic, okay, that's been rotated, okay, from the coordinate axis, instead of being parallel from the coordinate axis, if I have this bxy term, I cannot write this in standard form, okay? I cannot write this in standard form if I have this bxy term. Okay, so if I need to write it in standard form, then we're going to have to work on eliminating the xy term. Okay? So to do this, we're going to go ahead and bring up our ellipse that we have here. And we've got these two angles here, right? We've got this theta, and then we've got this kind of question mark theta. And I'm saying that this question mark theta is going to be 135 degrees, all right? And we're going to show why we actually don't want to reference this, okay? Instead, we want to reference this smaller angle by the end of this slide, okay? Okay, so first thing we're going to do in order to eliminate the xy term, we're going to substitute the x and y equations that we just derived in the previous slide, okay? Now when we do that, we're substituting into this conic right here, or this general form equation right here. Okay, that's what we're doing. Okay, now when I do that, I'll have an x prime y prime term, and this whole thing will be the coefficient for that x prime y prime term. Okay, now if we want that to go away, we're going to have to set that coefficient equal to 0. Okay, so then I'm going to go ahead and subtract c minus a sine 2 theta. Okay, so now I've got b cosine 2 theta equals negative c minus a sine 2 theta. Okay, go ahead and distribute that negative through, and then I'm going to divide by b and divide by sine 2 theta. Okay. I'm doing that so I can get my a, b, and c on one side, and then all my thetas on the other side. Okay. So coming up here, when we do that, I get cosine 2 theta over sine 2 theta equals a minus c over b. Okay, and then the left-hand side simplifies to cotangent 2 theta equals a minus c over b. Okay, and in this instance, our b cannot equal 0. All right. And we're going to find that our theta is always going to be in quadrant 1, okay? Meaning it's going to be in between 0 and pi over 2, okay? Okay, now let's think about this, all right? Since either our x prime or our y prime, okay, so one of these axes will 100% be in Q1, okay? Okay, we only need to instead of using, for instance, this 135 degrees, okay, we would rather use just 45 degrees instead, because that's still going to align our axes with the conic. It's the axes of the conic with the axes of the x prime y prime plane. Okay, so this new axes that we have, okay, one of the x prime or y prime is going to be in this quadrant 1. So we're going to take that angle, whatever that smallest angle is, it's going to be an acute angle. Okay, it's going to be between 0 and pi over 2. All right. So if you're ever tempted to say, use like this angle here, right, or this angle that we have, this theta question mark, okay, we don't want to actually do that, okay? That's making things a lot harder for ourselves. We're just going to use this acute angle in quadrant 1, and that's going to make our lives easier and allow us to eliminate the xy term nonetheless, okay? Okay, example 1, okay, we're going to write the equation and then identify the conic, okay, using pi over 6. So using pi over 6 as our angle, we want to write 7x squared plus 4 root 3xy plus 3y squared minus 60 equals 0 in the x prime y prime plane. Okay, so we're given our angle and we're going to rewrite it in this x prime y prime plane, and then we need to identify our conic. Okay, so first thing we're going to do, we need to find our equations for x and y. Okay, now we know the generic equations that we have here. Okay, so I've got one up here for x. Let's see, where is it? Here we go. Here for x, and then here for y. All right. Okay, so for x, we're given our angle theta. Okay, so we can really just plug that right in. Okay, so I've got x prime cosine of pi over 6 minus y prime sine of pi over 6. And then for y down here, I've got x prime sine pi over 6 plus sine or cosine pi over 6 times y prime. Okay. So then this is going to be, these are going to be our two equations for x prime and y prime. Okay, go ahead and box those. Okay, so our second step, we're going to substitute into the original equation. Okay, so I've got this whole equation for y, and anytime I see y in here, I'm just going to plug in what I have here on the left. Okay, and then I got this equation for x, so anytime I see an x here, okay, I'm going to plug that right in. All right, so I'm going to plug in this long equation with my x prime and y prime every time I see x in my original equation. Okay, so it's going to be pretty long, and you got a lot of opportunities for error, but that's all right. We can kind of take our time and work through it. Okay, so again, anytime I see x, now I'm plugging in this root 3 over 2 x prime minus 1/2 y prime. Okay, but now I've got that squared. Okay, so don't forget whatever's happening to x, I still need to have that operation when I make my substitution. Okay, then everything else gets substituted in just the same. Okay, so now we need to go ahead and we're going to distribute. Okay, we're going to distribute, or sorry, we are going to FOIL out this middle term, and then we need to take care of these squares also. Okay, so we need to go ahead and kind of expand both of these binomials here and here. All right, so when we do that, we get this big long equation right here. Okay, now I've got, notice I've got x primes and y primes all throughout. Okay, I'm no longer working with x's and y's. Now I'm working with x primes and y primes. Okay, so I'm going to go ahead and distribute, say, my 7 and my 4 root 3 and my 3. So I'm just distributing all of my coefficients now. All right, and I get an equation that looks like this, and we'll finish this up with a clean slide here. Okay, so at this point, all right, all of my x prime, y prime terms, when I evaluate these and I combine them, because at this point I'm just combining like terms, these should go away, okay? These should go away, and in this case they do, so that's good. Okay, and then we just continue to combine like terms, all right? So I've got my x prime squareds, combine those. I got my y prime squareds, I can combine those. And I've got this minus 60 over here. That doesn't combine with anything else. Okay, so this is going to be our equation here in the x prime y prime plane. Okay, Okay, now we need to identify the conic, and we're going to do that, okay, using A, B, and C of the original equation, okay? So again, I'm getting A equals 7 from this original equation. I get B equals 4 root 3, again, from the original equation, and C equals 3 from the original equation, all right? And now we need to take a look at our determinant, okay, which we looked at last video. So I've got B squared minus 4AC. I need to see what that determinant is. Is it above 0? Is it below 0? Is it 0? What is it? Okay, so I go ahead and plug in my A, B, and C, and I get 48 minus 84. 48 minus 84, this should actually be a less than sign, okay? So it's going to be less than, and that tells us that it is either going to be a circle or an ellipse, right? We went over that with our hyperbolas video, okay? When our discriminant, sorry, I think I said determinant earlier, it's our discriminant, okay? When that is below 0, we either have a circle or an ellipse, okay? When we're working with our general form equations here, okay? And then how do we tell if it is a circle or an ellipse, okay? If B is not equal to 0, or if A equals C, okay, then we have an ellipse, all right? If both of those are true, then we have a circle. But in this case, our B does not equal 0, okay, so we have an ellipse, all right? Okay, let's move on to our second example here. Okay, use a suitable angle of rotation for the conic with the given equation and write the equation in standard form, all right? Okay, so we're given our equation in general form. We're trying to get it to standard form. Again, we're going to start working with this cotangent to theta equals A minus C over B, okay? Now we're getting this A, C, and B just from our original equation, okay? So we've got A is equal to 57, okay? B is equal to 14 root 3, and C is equal to 43, okay? So we can just go ahead and plug those right in. And once we start to simplify this, it's going to be 14 over 14 root 3. And when I rationalize that, it's going to be root 3 over 3. All right. So cotangent of 2 theta equals root 3 over 3. So we can go ahead and start to draw a triangle of this. All right. And what the triangle to represent the situation would be something like this. Okay. Again, I've got 2 theta now inside my triangle. Okay, opposite leg is 3. Adjacent leg is root 3, and then I've got 2 root 3 on my for my hypotenuse, okay? Okay, we're going to have to use our half angle ID now, okay? And we're doing that because we need this in terms of theta, right? This is in terms of 2 theta right now, but we know that we have this half angle ID, and we can use that, okay? So what this says is now I can see what's cosine of this 2 theta. Okay, cosine is going to be adjacent over hypotenuse, so where I see cosine 2 theta here, I'm just going to plug that in right here, okay? So that's going to be root 3 over 2 root 3, okay? And I can start to simplify that, and I'll get 1/2, okay? So sine of theta is equal to 1/2. You might be thinking, well, why are we finding sine of theta? Why are we even doing that? Well, that's because we're trying to find these 2 equations right here, all right? And in order to do that, we need to have some sort of angle here, okay, for our cosine and our sine of theta, all right? So that's what we're doing. We're finding out what sine of theta is and what cosine of theta is, okay, starting off with this cotangent of 2 theta. Okay, so now we just need to figure out what cosine theta is. Okay, so again, we have our half angle ID. Okay, so now we're adding this cosine 2 theta here. Okay, so we're adding that now inside of our radical. Okay, and then we can go ahead and simplify that down to root 3 over 2. That's going to be our cosine theta. Okay, so now I can just plug in 1/2 and root 3 over 2 into this equation right here wherever I see sine theta and cosine theta. Okay, so now I've got this nice equation for x equals and for y equals. Okay. Okay, let's go ahead and keep working on this next slide. Go ahead and bring back up my 2 equations here. All right, so now we need to go through the trouble of plugging this back in. Okay, so wherever I see x in my general form equation, Okay, I'm going to go ahead and plug in this whole thing. Okay, and wherever I see y in my general form equation, I'm going to go ahead and plug in this whole thing. All right, so that's going to look something like this. Big long process here. Okay, and then now we can go ahead and start to kind of FOIL out our binomials and FOIL here as well. Okay, so again, we're just FOILing here and then taking care of these squares by just expanding these two terms in parentheses. Okay, so when we do that, it's just going to keep expanding out our equation that we're working with here. Okay, but again, now we're working with x primes and y primes instead of x's and y's, all right, which is the goal that we're going for. Okay, so this is the equation that we're working with. I'm going to go ahead and distribute our coefficients. So we'll distribute our 57 all throughout. Okay, and I'll do that with my 14 root 3 and my 43 as well. Okay, and this is what I get right here. Now at this point, all of my x prime, y prime terms should go away, and in this case they do, so lucky us. Okay, so those all cancel each other out rather. Okay, so now I can combine my x prime terms and my y prime terms. Okay, so when I do that, I get this 256 over 4 x prime squared plus 144 over 4 y prime squared equals 576. Okay, and then our fractions simplify a bit, and you can see this is kind of starting to look like maybe an ellipse or a circle, right? Okay, but in that case, we want to have what on this side? Or even a hyperbola, right? We want to have a 1 over here, right? We want to have a 1. So we're going to divide by this, okay? Divide by our 576 here, and we get this equation right here, okay? Okay, so taking a look at our third example, okay? If the equation for a gear after a 30-degree rotation, okay, in the xy plane, x prime, y prime plane, is y prime squared plus 4y prime squared minus 40 equals 0. Find the equation for the gear in the xy plane, okay? So now we're trying to go from the x prime, y prime to the xy plane, okay? So now remember we gave you these two equations earlier on one of the beginning slides here. Okay, so we just solved our equations that were solved for x and y. We instead solve those for x prime and y prime, okay? And we have our degree of rotation here is already 30 degrees, right? So now we can just go ahead and plug in 30 and figure out what cosine theta is and sine theta is because our theta is just 30, okay? And then we can plug those values in and find that x prime equals root 3 over 2x plus 1/2 y, and y prime equals root 3 over 2y minus 1/2 x, okay? And then we're, again, just going to start plugging those in, okay? We plug that into our original equation, get something like this, start to expand out, okay, all of these squares here, okay, we're just expanding those out, right? And then we can just start combining like terms at this point, okay? So we can combine our x squareds, our xy's, and our y squares, and our final equation is going to be 7 over 4x squared minus 3 root 3 over 2xy plus 13 over 4y squared minus 40 equals 0. Okay, so that's how we can go from the x prime y prime plane to the xy plane. Okay, last example here, we're graphing, okay, and we're going to use our graphing calculator here. But first we need to kind of work with this equation that we are given, okay? And to do that, usually we have y equals something, right? If we're graphing a y equals function, okay? So we need to rewrite this in a way that we can actually graph that, okay? So we need to start thinking, how can I rewrite this in a way that looks like a quadratic, okay? And what I mean by that is, let me get all of my x squareds, all my x squareds over into the front. And then what are all my y terms? Okay, well, I've got this xy term, but I'm not really worried about x right now. I just want to know what terms have a y with a degree of 1 in there. Okay, so I've got this minus 6xy and minus 20y. Okay, so I would go ahead and bring those two together. So what I did here, so we have minus 6xy minus 20y. Okay, and then I just factored the y out of those two. Okay, and that's how I got this second term right here. So I have negative 20 plus 6x, or sorry, negative 20 minus 6x, all in parentheses, y. Okay, and then anything that does not have a y, I've just got in parentheses all off at the very end of my equation here. Okay, so now hopefully you can start to see I've really got this equation that looks like ay squared plus by plus c equals 0, okay? Which you guys have seen before, except it was ax squared plus bx plus c equals 0, right, with our quadratics. Okay, so our quadratic formula now, instead of being x equals something, now it's y equals something, okay? And that something doesn't change, okay? This is still our quadratic formula on the right-hand side. Now we're just solving for a y instead of solving for an x like we've done previously. Okay, so now we just have to think, okay, well, what is my a? Okay, well, we already showed it here. Okay, a is 2. Okay, and then my b is this negative 20 minus 6x. And then my c are all of these terms here that don't have a y in them. Okay, so I know they have an x in it, but that's fine. I can just think of these x's as I would have thought like a constant would be for my quadratics. Okay. Okay, so now I just go through the process of plugging everything in. Okay, so wherever I see a b in my quadratic equation or my quadratic formula, I plug that in. Okay, plug it in here, minus 4ac, and everything's kind of color coded here, all over to a. Okay. And then we just got to start simplifying. Okay, now technically you could plug this in to your calculator. Okay, it's just going to take a little bit. You might make some mistakes with some parentheses. So I'm just going to simplify this down a little bit. Okay, so I'm just going to FOIL out this squared term here, and then we're going to multiply this by 2 and then distribute that throughout this term here that we have for c. Okay, so then we can continue to simplify down. We can factor out a 4 inside of our radical, and then that brings out a 2 out in front of the radical, and then we can simplify one more step by dividing everything and simplifying by that 2. Okay, so this is what I would plug in to my calculator right here. Okay, y equals. Okay, so what we would actually have to do, because remember you do have this plus or minus right here. Okay, so what it would look like in our calculator, I would have 10 plus 3x plus, okay, and then my radical, and then I would have 10 plus 3x minus, and then my radical here. Okay, and this is what the graph would look like in your calculator after it's all said and done. All right, so that is all we have for rotated conics. I know that was another long one, but good luck with your practice.